Okay, so we're generally going to see a couple of kinds of exponentials, and this is the easier one. If you saw one like 3 to the x equals 2 to the x plus 5, this one would be much harder because you can't write these bases the same, and that's where you're going to have to use logs to solve. That's not what we have on this one. For this one, we have this base is 25 and this base is 125, and we can write them with a common base. So if we can write them with a common base, like say the base is a, if I have a to the x equals a to the y, whatever these may be, that means that x has to equal y. So if I can get these to match, which I couldn't with the 3 and the 2, then I have a good way to solve it. So this would go 5 squared x, because 25 is the same thing as 5 squared, and this would be like that. Let me write it that way for a second, and I'll clean that up in a moment. And then this would be 5 cubed, would be 125 to the x plus 5. So when you're raising something to a power, which is what we're doing here, that means those would multiply. So that would be 2x would be the simpler way to write that. And usually when I did this in the video, clean that up, I probably wrote it as 5 cubed x plus 5, but this is just to kind of show the common base. That's how I would usually go with it though. So now I have 5 to the 2x equals 5 raised to the third times that x plus 5, which means I can just equate the exponents together. So 2x equals 3x plus 5. Distribute the 3 across. 2x equals 3x plus 15. I'll isolate x, so I'm going to bring the 3x over this way, and that'll give me negative x equals 15, or x equals negative 15. And that's all there is to those. So anytime you see something where you can write a common base, like if you had 9 to the x over 1/3 to the x plus 2, right there you can see you could do something with the 3's. 3 squared x, 1 over 3 would be 3 to the negative 1, x plus, I think I said 2 when I wrote that. But it's that same idea where you see 9s and 3s or 9s and 27s, anyhow, something that you can get a common base with that allows you to set exponents equal. And again, much easier if you try to do this one with logarithms, it's actually a pretty hard problem. So that's the way I would go on that one.